Hello, this is Lab 5, Choose Your Own Adventure. This week I wanted to calculate the pressure inside of a champagne bottle. Here's the setup. The bottle cap's mass I determined, the bottle cap's radius, important for the aerodynamics, and the radius inside the bottleneck, important for determining the pressure in the end. Bottle's initial position is 0, little g is important, delta t, the time between the frames, is 0.042 seconds, and the total observation time from deployment of the bottle cap until it crosses the y is 0, the y is 0 line again is 2.39 seconds. While I'll let the observation run here, I'll continue explaining. Calculated the initial velocity subtracting the position number 2 from position number 1 here in the very beginning over delta t, and I get this value. The forces involved is the force of gravity and the force of drag. I use this formula. For the drag coefficient I used 0.4. The air density was based on 20 degrees Celsius, and the aspect ratio calculates by using the radius of the bottle cap times the magnitude of velocity squared times the unit vector of direction of velocity. Here in the Python code you see this information here. The initial conditions, wherever you see ball, this is cap. So mass, position, velocity, delta t, very small, little g, r hat, drag coefficient, air density, and the radius of the cap, pi, and the aspect area. Now I calculated, which is not really relevant for this, for calculating the pressure inside the bottle, I calculated the net force and predicted the velocity using Newton's second law again. And you can see this in the code down here, using Newton's second law for the velocity prediction and the position, and using the law of kinematics for the position prediction. The formulas for the weight force and the drag force are here in the code. So when I run the code, we just see the trajectory of the bottle cap. I'm hoping it runs all the way through. Now, no, not quite. But anyhow, to calculate now, determine the pressure of the inside of the champagne bottle, we divide the force, the magnitude of the force, over the area that the pressure is exerted on. So the magnitude of the force is the final momentum minus the initial momentum. The initial momentum is 0 because the bottle cap has no momentum, is at rest. And then the area calculates by using pi times the radius square. So solving for the pressure, I get a value of 947 pascals. This is approximately 0.01 atmosphere, and I Wikipedia'd the actual pressure inside of a champagne bottle. It's 5 to 6 atmospheres. So I made a calculation mistake in here, and I apologize, but I'm running out of time to correct this, and would appreciate it if you saw my mistake looking at my video. Thank you very much.